answers up online. They're here somewhere, and I'll put them up there. But we can go over any of the 15 questions that you want to go over. And tomorrow's test is going to have 10 questions total. So it's going to be similar to this, but there's only going to be 10 questions.
Number 6.
How about 3, 6? All right.
Is it multiple choice?
No. No. Be nice to people. All right. For number 3. Now, when we deal with these types of problems, when we deal with a rational expression or a rational function like this, and it asks us to find holes and asymptotes, what we need to do is we need to determine whether or not any of the factors are removable or non-removable. And so what we need to do, like for number 3, is in the bottom we have 2x minus 1. And we have to determine whether or not that is removable. If it's removable, it's a whole, meaning that we can divide it out. So we're going to have to take that 6x squared plus 7x minus 5, and we're going to have to factor this. Multiply the two numbers at the ends. What do we get? Negative 30. So I need two numbers that multiply to get to negative 30 that add up to 7. All right, negative 3 and 10. I like that. Negative 3 and 10, negative 3 and 10. Six x squared there, negative 5 there, negative 3x, and a positive 10x. Now, I'm going to factor 6 and 3 is a 3, x and x squared and x is an x. And here I have a positive 5. So I know I'm going to get 3x plus 5 up there. Now, 6 and 10, that'll be a 2x. That's a minus, so I'm going to have a minus there. And 1, so I'm going to get 2x minus 1. So, now, can I divide them out? Yeah, that guy divides out with that guy. So, I'm going to have a whole where 2x minus 1 is equal to 0. Add 1. So 2x is equal to 1. Divide by 2. X is equal to 1/2. So I'm going to have a whole at x equals 1/2. Now, in order to figure out what part of the graph that's going to be, just plug it into the part that didn't get divided out, because those two parts divided out. So I need half of 3 plus 5. So what's half of 3? 1.5 plus 5, which is 6.5. So I know at 1/2, 6.5, or you could say 0.5, 6.5. That's where the hole's going to be. Yeah, that's it. Biggest thing with rational expressions are you're going to factor and see what divides out. If it divides out, great. If it doesn't divide out, then it's going to end up not being exactly what we wanted it to be. So the answer to this one is, yeah, it's a whole. It's a whole at x. X equals 1/2, and then we can actually go one step further and find the coordinates of it. Yes?
Can you also do it for four?
Sure. All right. Now for number 4, can I factor the top?
Yeah.
I need two numbers that multiply to get to 8, that add to get to a -6.
-7.
All right. So I have x minus 2, x minus 4, and x plus 4. Is there any? Can I divide out the x plus 4? All right. So I can't divide out x plus 4. So set x plus 4 equal to 0. Then we get x is equal to -4. And that's going to be my vertical asymptote. So nothing can divide out here. Are there any holes here? No holes at all.
And if you want to find the other coordinate?
Well, there are no other coordinates. Because what we'll end up with is at -4, which is right here, you'll get a vertical dashed line where the function won't exist. All right. Now, any questions on that one? On to number 6. Now, for number 6, 3 times 8. What's 3 times 8?
24.
24. So I need something times something is 24. And they should add up to be 14.
Two and 12.
2 and 12? All right, so what I'll do is get 3x squared there, 2x, 12x, and positive 8. Now I'm going to factor out this way because I ran out of space. Well, I could do that here. Common factor between 3x squared and 2x?
X.
X. Between 12x and 8?
4. Wait, no.
Yeah, 4. All right, so I know I have 2x plus 3, and my first factor that I got is x plus 4. So far, that can't divide out there. So this is going to give me a vertical asymptote. Now, here, 3 and 12, that's a 3 and that's an x. So I know I'm going to get 3x. That's positive, so plus. 2 and 8, that's a 4. So that's a vertical asymptote too because that's not divided out. You can't divide any of that out. So I have 2 vertical asymptotes now. Oh, 2. Same thing. You're right, that's a 2. All right, so now I take that guy, say x plus 4 equals 0, so x is equal to negative 4. Then I take 3x plus 2 is equal to 0, so I get 3x is equal to negative 2. And so I get two vertical asymptotes. So I'd end up graphing both of those.
That's the answer.
So here's one. Your vertical asymptote is right here. Here's another one. And then that's all you need. There are no holes in that one. And you're just finding vertical asymptotes in that case. Now, for number 9, it's going to say, all right, well, find all the holes in all the vertical asymptotes. So you're not looking for a specific thing. You're looking to see which one's going to happen. And when you have a cubic function like this, we're going to factor by grouping. So we'll group together x cubed plus 3x squared plus a negative 4x minus 12. Now, what is the common factor of the first group?
1.
All right, for the number it's a 1, but I have an x cubed and an x squared. Which one comes out? X squared, the smallest power. So that's x plus 3. Now I have a negative 4x minus 12. I'm going to factor out a negative 4 because it's negative and negative. And then if I divide it by that, that's a positive x. Negative 12 divided by negative 4 is a positive 3. Did I get the binomial that I wanted?
Yeah.
Absolutely. So I'll take out that x plus 3, but I'm left with x squared minus 4. Can I factor x squared minus 4?
Yeah.
Yes.
Is it x plus 2?
Yeah, this guy is your difference of squares. A squared minus b squared. Then you have to use other paper if you do not have space. All right, so now let's take a look at the function itself. So we're going to rewrite the function. X plus 2 is in the top. I have x plus 3, x plus 2, and an x minus 2. Can I divide any of them out?
X plus 2.
All right, yeah, the x plus 2 can get divided out. So let me kind of move this up now. And I can divide those two out. So if I can divide it out, is it a whole or is it an asymptote? All right, it's going to be a whole. So I know this guy's a whole. Can I divide out the x plus 3?
No.
No. So it's a vertical asymptote. Can I divide out the x minus 2?
No.
No, it's a vertical asymptote. So you have to go through and find all the x values. So at this point, x plus 3 is equal to 0, so x is equal to negative 3. That's a vertical asymptote. I'm going to use the other vertical asymptote. X minus 2 is equal to 0, so x is equal to 2. Then x plus 2 is equal to 0, so x is equal to negative 2. These are my vertical asymptotes. And my hole is here. Now, at negative 2, if I plug that in, that's a 1, and that's going to be a negative 4, so it's going to be negative 1/4, because you'd multiply those. That's a negative 4. That's a 1. So negative 4 times 1 if I plugged in that negative 2. So I know the whole is going to be at negative 2, negative 1/4.
Do you have to plug it into both of them?
Yeah.
Oh, what's it? It's random. It's not. What do you got?
What?
One photo?
When you have a whole -2, then where you should plug a -2 in both.
In both. And because this,
So you have two.
that part is basically gone. So to figure out the value that the function would have had at negative 2, we take out the part that would make it undefined because that's gone, and plug it in here, and it'd be, you get a 1 and a negative 4, so it's 1 times negative 4, which would be negative 4. Yeah, because you're multiplying everything in the bottom anyway.
So like we're gonna take x and you still have a 1 up top.
Yep.
You have to put 1. Even if you have only one number, you have to put 1.
Yep. All right. Now there was a question on this guy on how to actually graph this, because you will have to graph. All right. I need to rewrite this. I know it's x plus 2 up top. Do I know of two numbers that multiply to get to negative 14 that add to a negative 5?
2 and 7.
All right, so which one's negative, though?
So the 7.
All right, so I'm going to get x minus 7 and x plus 2. Negative 7 times 2 is going to be the negative 14, but if I have negative 7x plus 2x, that's going to get me a negative 5. Things are working good. Now, do I have a vertical asymptote anywhere? X minus 7. So I'm going to say x minus 7 equals 0 because I can't divide that one out. So x is equal to 7. So at 7, I'm going to put a dashed line. Do I have a hole anywhere?
Negative 2.
At negative 2, because these two can divide out. And if those two divide out, I'm going to get x equals to negative 2, and then I'll plug that into here. Negative 2 minus 7, which is
Negative 9.
negative 9. So I go to negative 2 and negative 9, and I'm going to put a hole there.
Does it matter if your whole like shaded just go circle? But whatever.
We should do the table, right?
Yes.
For the whole, the one that's in the actual equation is the x, right? X on the x-axis. And then the one that you find afterwards is y.
Right. And actually, this should be 1 over negative 9. So it should be way up here.
Why is it 1 over? Oh,
Because in the equation, it's 1 over. Because it's in the denominator.
okay.
So when you plug it back in, you're really plugging it into this. All right, so now
We should do the table, right?
we got to ask ourselves, is this going to have, what type of horizontal asymptote are we going to get out of this?
All you're gonna be
Is it going to be at 0?
Negative 2.
Now, look at the degrees.
the bottom that's bigger than
What's my m? What's the top degree?
1.
1. What's my n? 2. Which one's bigger?
The M.
Bottom.
So m is less than n. So y equals 0 is my horizontal asymptote. So I can take this, and y equals 0 is the x-axis. And since I know this point's here, let's take some points to the left and to the right of the graph.
What if the M was greater than N?
Then there'd be no asymptote. All right, let me zoom this out. And oops. And the vertical asymptote's at 7. So I'm going to go 6, 5, 4, 8, 9, 10. If I put an 8 in here, and it's x plus 2 over x minus 7 times x plus 2. If I have x equal to 8, I'd get, what's 8 plus 2?
10.
10 over what's 8 minus 7?
Can you move a little bit?
10.
Alright, so it'd be 10 over 1, and then what's 8 plus 2?
10.
10. So what's 10 over 10? 1. So I know it's undefined there, but it's 1 there. Now, what if I got x equal to 6? If I got x equal to 6, I'd get an 8 up here. What's 6 minus 7? Negative 1 over 8. So this is going to be equal to negative 1. Now, do you see a relationship between these? Yeah, they just change values. So let's plug in x equals 9. See what we get. What's 9 plus 2? 11. And then 9 minus 2, or 9 minus 7 is
2.
2. And then I got another 11.
So it'll be 1 over 2.
Multiply, don't add. It ends up being 1/2. So what do you think this value is going to be? Negative 1/2. So we're going to use this idea of symmetry between both sides. They're mirror images of each other. If this is a positive, this is negative. And then I'll put in 10. 11 divided by 11, they're gone. So there's 1. Well, 2 because 9 minus 7 is 2.
Yeah, so don't you multiply the bottom?
Yep.
You get 22.
11 over 22. You would have had 11 over 22. You could divide out the 11s and you're going to get 1/2. So if x equals 10, in the numerator you get a 12. Now what's 10 minus 7?
17.
3.
But don't you?
10 minus 7. So I get a 3, and then I get 10 plus 2, which is 12. These two divide out, carry the 1, that's 1/3. So I get a 1/3 here and negative 1/3 here. So I'm going to plot these points. At 8, it's 1.
Can you go to graph?
What was that? Yes. Because what's going to happen is there's going to be a graph up here and there's going to be a graph down here. There's two with rational functions, you're going to get either 2 branches that will look like. like that, or you'll get something like this. So you have to make sure that you work on both sides of the asymptote.
So we get the vertical asymptotes in the hole, and then you make a little value.
Yes.
How did you get number 10? Like 1 over 3.
I plugged in 10 plus 2, which was 12. So 10 plus 2, which was 12. 10 minus 7, which is 3. And then 10 plus 2 again, which is 12. All right, so now I plug in these values. I got my 1 here. I got 1/2, 1/3. And so what's happening is the graph is going towards the horizontal asymptote, and it's also going towards the vertical asymptote. It's never going to touch either one. It's never going to touch the x equals 7 because it'd be undefined, and it's never going to touch 0 because there's no way that you can make it into 0. I need points. I'm going to need points. I know at 6, it's going to be a -1, which is right there. And then it's doing that as well. And so it's going to do that as well. And you make the best graph that you possibly can. And then, just to highlight it, so you can see the graph a little bit better.
So all 10 of them is graphing?
No, it's going to be a lot like this. It's going to be, if you want to think about what type of things are going to be, it's not going to be, all right, find the hole and find the vertical asymptote. It's going to be like these guys. It's going to be, all right, here's the rational function. Find all the holes and asymptotes. Then it's going to, there's a few that are graphing, and then there's a few like this. Now, do we all understand how to make these? Anybody want to see one of these? 15? 15, since it has the most stuff going on.
You did number 13 or 14.
All right. Now, if it's a hole, it's removable. So I can do an x minus 3 over an x minus 3. Remember, you have to use the opposite of what you see. And since it's removable, because I can divide those out, we end up with a hole, because that's what the hole is going to give us. It's where the factors can divide out. Now, since I have x minus 4, x plus 4, x plus 4. So this is going to give me a hole. That's going to give me a hole. Now I need a vertical asymptote. It's non-removable, so I'm just going to put it in the bottom. There's my vertical asymptote. Now, for this guy right here, when you have a fraction, take the fraction and now I want it to where it's 0 on one side. So multiply 2 and get 2x is equal to -1. Add a 1 to both sides. So you get 2x plus 1 is equal to 0. This is, that's what we'll put in here, 2x plus 1. No, they go in the bottom. We're always going to put stuff that's in the bottom. If you would have put x plus 1/2, it would have worked. But it's neater to multiply both sides by 2.
The question was like, can you put x negative 5 in the top and put x in the bottom?
No. All your holes in your holes and vertical asymptotes are from the bottom. from the denominator.
Oh, yeah. So every,
Because it's where the function doesn't exist. So these are zeros of the denominator.
so how come like in 8 or 9 we took the whole from the top? Or we factor it and we're supposed to take it from the bottom?
This was what we were keying on.
So like every time it's from bottom.
Every time it's driven from the bottom.